Hey everyone, in this video we are going to be talking about doing math with our significant figures. But in order to do that, we first have to talk about rounding with our significant figures. So if I am rounding to the right of the decimal, let's say we were told that we needed to round to 3 sig figs, 67.3735. Okay, well, the first thing that I've got to do is I got to figure out where are these 3 digits at. So I know all these numbers fall under that 1 through 9 category. They're all significant, or all these digits. So I would go 1, 2, 3. Well, my next step is to remove unneeded digits. And what that means is if I know that I'm going to need just these 3, then I'm going to remove the unwanted ones, or the ones that I don't need. So what that looks like is these are going to get removed. Okay, then my next step is to round up if necessary. So what that means is after I have removed my digits, so I am left with this 67.3, okay? I then am going to look at this digit that is beside of it. So in this case, it was a 7. If it is greater than 5, that means I'm going to round up, or I'm going to kick that number up. So 67.37 is really going to be 67.4. Now, some of you may be like, well, I know this. We've done this before. I know you've done this before, but this is just a refresher for you. Now, what you're typically going to see is what we just did. But I do want to talk a little bit about scientific notation and what to do with that. So here's how you round to the left of the decimal. So let's say that they told us that we needed to round to 2 sig figs, 8, 3, 4, 5, 2. Okay, well, in order to do that, we have to change that number to scientific notation. And the first thing that we have to do in order to do that is we have to move the decimal place in between our first 2 digits. So I first have to find my decimal place, which is going to be here at the end of this number. And then I'm going to count how many times that I move it. So 1, 2, 3, 4. Okay? So that means that I would have 8.3452 times 10, and then the raised part is going to be, this exponent is going to be your number, and let me do that in a different color. Of places moved. Okay, and then our next and final step is going to be to remove unneeded digits. And if you remember, we were told that we needed to go to 2 significant digits all of these are 1 through 9. So if I go through and count, this would be 1, 2. If I look at the number beside of it, it's a 4, so I'm not going to need to round up. So my final answer for this one would just be 8.3 times 10 raised to the 4th. And that times 10 raised to the 4th does not affect your significant or being insignificant. It's just kind of added on to the end. What does matter, though, is the beginning part with the digits. So that is what it looks like to round. And the reason why we have to know how to round is for the next thing that we're going to talk about, which is calculations in sig figs. And that C with the 2 dots, that is the and symbol. So when we're doing calculations, our first rule is going to be for multiplying and dividing. And that rule states that we have to round, there's that rounding, our answer. So round answer to the smallest number of sig figs used in the calculation. And by calculation, we just mean whenever you're multiplying or dividing. So we're worried about the smallest number of sig figs. So we need the least amount of sig figs. So let's say, for example, we were given 4.32 times 7.301. Well, we have to go through and we have to assign our categories to all of the digits and all of the numbers being used, because we've got to figure out which number, 4.32 or 7.301, has the least amount of sig figs. So in this case, all of these are 1 through 9. They're significant, so we have 3 sig figs. Over here, 7, 3, and 1 are 1 through 9. They're significant. But then this 0 right here, it is sandwiched between our 1 through 9 numbers. So it's got a 3 and a 1 on either side. So it is significant. So that means that we have 4 sig figs. So between 3 and 4, which one is smaller? 3. So that means that we need 3 sig figs. So now what we're going to do is we're going to go through and we're going to type this in our calculator. So we're going to type 4.32 times 7.301. When you do that, you're going to get 31.54032. Now we need 3 sig figs. So we've got 1, 2, 3. I have to look beside of that third sig fig. Whenever I look at that 4, okay, it's not going to cause me to round the 5 up. So my final answer is just going to be 31.5. Okay. Now, the second rule, if we've talked about multiplying and dividing, rule 2 is for adding and subtracting. And what rule 2 says for adding and subtracting is that we have to round our answer to the smallest number of decimal places used in the calculation. So this time, we don't care about the number of sig figs. Like, we're not even going to look at sig figs. All that we care about is the decimal places. So basically, are you in the tens, the hundreds, the thousands place? You want the smallest number of decimal places. Now, the easiest way to do this is to line up your decimal places. And you may be thinking, what do you mean? So let's say I was told that I needed to do 3.678 plus 2.112. Well, what I'm going to do is I'm going to line up my numbers to see my decimal places. So what that looks like, and I'll write this here, is I'm going to start out with this 3.678. Then we have 2.12. So that means that I want my decimal places to line up directly. And what I mean by line up directly is that they're one on top of the other. Okay? Then we add. So I'm going to do the math. So here we would have 897.5. Now, I'm going to go in here and I'm going to draw a line beside of this 8. So do you see how this 8 right here doesn't have a number underneath it? Okay, that means that it has one more decimal place than the number below it. Okay, so what I then know is that I need to keep this number of decimal places, because in this, okay, I can see that they both have this many decimal places. Now, when I go to round, this 8 is bigger than a 5, so that means I'm going to have to round this number. So my final answer would be 5.80. Okay, now I'm going to give you 2 problems that I want you to try on your own. So the first one is 29.51 divided by 3.2. So take a minute, pause this video, and then work it out, come back, and see whether you were correct or not. Alright, I trust that you have done this. So first we got to figure out, what are we doing? What operation? We're dividing. If we're dividing, then we care about our sig figs, which means that we have to go through and figure out how many sig figs each of these has. But lucky for us, they're all 1 through 9. They're all significant. So here we have 4. Here we have 2 sig figs. So that means in my final answer, I need 2 significant figures. So if I go through and I do the math, I'm going to have 9.221875. And again, I need 2 sig figs, so 1, 2. I'm going to look at the number beside of it. In this case, it's below, or it's smaller than 5, so I'm just going to have 9.2 as my answer. Okay, the next problem that I want you to try on your own is 35.7682 minus 33.2. So again, take a moment, pause, and then come back and see whether you got this correct. So I trust that you paused the video and worked this out. Now we are subtracting, which means that we care about our decimal places. So that means that I need to line the decimal up in these numbers. So I want to start with 35.7682 and then 33.2. And now I'm going to draw a line beside of where I see that I have 2 numbers lining up, and then there becomes a point where only one number has digits in it. And what I mean by that is this. So here I can see that the 7 and 2 are on top of each other, but then with the 6, there's no digits underneath it. That's going to be my dividing line of how many decimal places do I need. So here, 2, 8, 6, 7 minus 2 is 5, and then 5 minus 3 is going to be 2. Now, I look to the right of my line. I see that this is a 6. That means I have to round up the digit on the other side of the line. So I'm going to be left with 2.6 as my final answer. And that is it for this video on using our significant figures in our math calculations.